Welcome back, everybody. Today we're going to start our next chapter, Chapter 8. And in Chapter 8, we're going to continue our look at Java data structures. Now, as far as data structures we've already talked about, we've covered the most basic, which was arrays, Java arrays in Chapter 6. In Chapter 7, we looked at something a little more complicated, array lists. Next one we're going to look at in Chapter 8 is something called 2D arrays, as in two-dimensional arrays. Let's get going with that right here. I'm going to say that a two-dimensional array is a complex data structure that can be visualized as a grid made up of rows and columns. Okay, so when I say 2D array, think table, think matrix, okay, think just like a spreadsheet. Okay, and a lot of times, rather than having just a long list of unrelated data, okay, we want to put that data into more of a table form with relationships between rows and columns. That's exactly what a two-dimensional array is intended for. So we can visualize our two-dimensional arrays as tables of values, but technically what's happening is a two-dimensional array is a one-dimensional array of one-dimensional arrays. So when we create a 2D array in Java, what's happening is Java is actually creating a single one-dimensional array, and each spot or each element of that one-dimensional array is going to be pointing to another one-dimensional array. Okay, in certain cases, we'll be able to ignore that detail and just kind of think of this as a table. Okay, we'll be able to abstract the details away. But in other cases, to actually get down to the nitty-gritty and make these tables do what we want, we will have to think of them in terms of the way Java is actually storing them as in arrays of arrays. Okay, that is the idea of extraction. That is kind of the balancing act we have as programmers here. Sometimes we can think at the high level, other times we have to think at the low level what's actually happening. And we'll give you some practice doing that as we run through here today. So before we jump into the details of 2D arrays, let's remind you about kind of 1D arrays and how they work, just so we're not confusing them though with array lists here quick. Okay, an array is a group of items, all the same type, which are accessed through a single identifier. So in Java, if I want to create an array of ints, I'd say I want an int with the braces for array. We'll give it a name nums, and then we'll call the new constructor to assign it. And what this is going to do is it's going to create a space in Java's memory to hold 10 int values like so. So if I want to make a two-dimensional array then, I have to remember that a 2D array is an array of arrays. So if I want a table essentially to hold ints, what I'll do is I'll say int braces braces as in array of arrays. We'll call that array arrays just because. We'll say it's a new int brace brace, and just like we sized at this point the one-dimensional arrays, we'll do the same thing with 2D arrays where the first number is the number of arrays I want. So if I do this int brace 3, that's going to create a space for Java to hold 3 different int arrays. And the second number, the 4 here, is going to be the size of each array. I want each of those arrays to hold 4 values. Okay, so my result would be a table that starts off with 12 zeros. Okay, kind of 12 empty spots to hold ints. And I can create my 2D arrays the same way for other data types. So for example, if I want a two-dimensional array to hold doubles, I'd say the type I want to hold, double, square brace, give it a name, and they'll say new double 2D array with, in this case, holding 3 different 1D arrays or 3 rows, and each of those arrays will have 3 spaces, or in other words 3 columns. Okay, this will fill dmat as in dmatrix with 9 0.0s, okay, 0.0 being the 0 value for doubles. And I can do the same thing if I want a 2D array of booleans. We'd say boolean, square brace, we'll call it boos equals new boolean 5 4. Okay, this would give me a boolean array with 5 rows, 4 columns, okay, filled with 20 falses. Okay, false being the 0 value for boolean. Or we could talk about strings, which will lead into other types of objects, okay, which we'll talk more about in the next lesson. But if I want an array of strings, we'd say a 2D array of strings, we'd say string brace, brace, words equals new string array 4, 2. In other words, I have 4 rows and 2 columns. Okay, and this array would start off filled with 8 null values. Okay, with null being the 0 value for strings or any other type of objects I look at. Now, just like I can instantiate a regular array by setting an equal to a list of values between curly braces, I can do the same thing with a two-dimensional array. So in the code, for example, on the left side of this equal sign, I'm declaring a two-dimensional int array called table, and I'm going to set it equal to, notice what I have here, it's a list of lists where each individual list or each individual array is between curly braces and separated by commas. So it looks like I'm making a 2D array with 1, 2, 3 arrays in them. Okay, with an extra set of curly braces to kind of surround the whole thing. All right, that would result again with a single dimensional array pointing to 3 different single dimensional arrays. And notice kind of the advantage of doing things this way as opposed to using my new array constructor is I can make what's called a jagged 2D array where each row has a different size to it. Okay, I can't do that with the new constructor, but I can by assigning it to lists of lists. So we have 2 different ways of creating 2D arrays. Now, next thing we're going to do is talk about how I reference the elements to get their values and set their values. Let's say, suppose 2DR is a reference to the following two-dimensional array. So it looks like it's a 2D array holding 3 rows or 3 1D arrays, with each row having 3 columns, okay, or 3 elements in each 1D array. If I write the code 2DR brace 0, what that's going to do is it's going to refer to the first array in 2DRs, so that's going to give me access to this array with the 5, the 7, and the 1. Okay, same idea. If I said 2DR brace 2, that's going to refer to the third array in 2D array. Okay, so my arrays are 0 index, going from 0, 1, 2, the third one. Okay, so this code here would refer to the 8, 11, 4 array. So I could access the entire arrays held within that 2D array, or I can access individual elements using 2 numbers. We can say a 2DR 1, 2, 1 in the first brace, 2 in the second brace, refers to the third element in the second array. Okay, so as in the first 1 tells me which of the 3 arrays to go with, okay, this middle one, and the 2 tells me to go to 0, 1, 2, the element there, the 0. So if I'm thinking in terms of single elements at a time, we could say that every cell in a 2D array has a pair of coordinates based on its row and column. So here are my arrays or my rows indexed from 0, 1 to 2. Columns, same idea, indexed from 0, 1 to 2. And I can access the individual elements by, for example, if I want the 8 here, I'd reference it by the row first, the 2, and then the column, the 0. That gives me access to this individual element. And I'll use the same notation to assign values. So for example, if I go int brace brace mat equals new int array 3 by 3, that's going to make an array with 3 rows and 3 columns. And if I want to assign a value, I will say which row I want to work with first, okay, or which array, and which column or spot in that array I want, and we'd set equal to 2. Okay, that's going to take our array filled with zeros initially and set the 0th row and first column equal to 2 here. And then just as another example, we can make an int 2D array with, that is 5 by 5, so 5 rows, 5 columns. And then this code here just set some of those values. Remember, they all start as 0. Okay, if I use the new constructor, then I got to set them individually. So if I go mat 2, 2, get 7, I'd go to the second row, to the second column, indexed by 0 once again, and set that to a 7. Okay, mat 0, 3 gets 5. I'd go to the 0th row and the third column, put a 5 there. Mat 4, 1 gets 3, would take me to the 4th row and the first column, 0 indexed, and set that equal to a 3. Now that notation is going to work the same way for arrays I instantiate with a list of lists. Okay, it's going to work the same way if I want to access things. So if I run this code to set a 2D int array called mat, set equal to these 1, 2, 3 arrays, calling mat21, again, printing that off would give me access to the 1, so the 0, 1, 2 second array at index 0, 1. So I should get a 7 when I do that. Yep, same idea. Mat at 1, 2 is going to go to the 0, 1th array at 0, 1, 2th element. Should print the 4. Okay, mat 0, 3 will go to the 0th array at element 0, 1, 2, 3. That'll print the 2. Let's see what the last line of code does. Mat at 1, 3. That would give me a runtime error, index out of bounds. Well, let's see why. Well, if I'm in the first array at spot 0, 1, 2, there is no third spot here. Okay, so we want out of bounds. Okay, something to watch for, just like when working with regular arrays, especially when you're dealing with jagged 2D arrays like this, just because since each individual array may have different sizes, you're going to have to account for that as you're writing your code. Okay, and we'll show you how to do that as we go through the rest of the way here. Next thing we're going to talk about is the length variables for a 2D array. Now, just like with a regular array, the length of a 2D array is a variable. And when we're talking length of 2D arrays, there's really two different dimensions to take into account, kind of the number of rows and the number of columns. We'll say the number of rows in a 2D array is found by accessing its length variable. And then if I want the number of columns in a 2D array, it's found by accessing the length variable on any 1D array from the 2D array. Let's show you what we mean by that. So if I run the code, two-dimensional int array called nums equals new int brace 5 brace 7, that's going to create a two-dimensional array of ints with 5 rows and 7 columns. So if I run the code then nums.length, that's going to give me the number of rows in my table here, which would be 5, this first number. And if I want to know how many columns are in that table or that 2D array, what I'll do is I'll access any one of those rows. So we'll say nums at 0, in other words, the first array in my 2D array, dot length. That'll give me the 7, the number of columns, or in other words, the number of elements in each individual one-dimensional array. Okay, now with this one, since it is a rectangular matrix that we created using the new 2D array constructor, when I call nums at 5 dot length, we'll get the same thing, the same 7, okay, because each of these rows are going to have the same number of columns. And those length variables are going to work the same way if I instantiate my 2D array using a list of lists. So for example, if I have nums equal this jagged 2D array here, and I run the code nums.length, that's going to give me the number of individual 1D arrays, or the number of rows, which in this case are 3, for the 1, 2, 3 arrays that make up this 2D array. And now the difference here is that each time I call the length variable of an individual row, since this is a jagged array, I'll get something different. Okay, nums at 0, so as in the 0th row dot length, will give me a 5 for the 1, 2, 3, 4, 5 elements in that first array. Nums1 dot length will give me a 3 for the 3 elements in that second array. And nums2 dot length will give me a 4 for the 1, 2, 3, 4 elements in that fourth array. Again, when dealing with jagged 2D arrays, that is something you have to account for. Each row could potentially have a different length, and we'll show you how to deal with that as we get into transversing in a second here. So last thing we're going to do is take a look at how we can traverse a two-dimensional array. So let's say I have this 2D array of ints called mat, as in matrices. that is a jagged array, 2D array, set equal to these 1, 2, 3 lists here. Well, if I want to go through every single element in that array, and let's just say print them off for this example, what I need to do is I need to start by going through every single row or every single 1D array. And for that, I'll go for int, we'll just say row equals 0, so as in starting with the 0th row. We'll run while row is less than mat.length. Remember where just mat.length is going to give us the number of rows in that 2D array. And then we'll go row plus plus, we'll go up by 1 row every time. So that's going to go through the rows, and then we'll need an additional inner loop, so nested loops here, to go through each element in each row. And the trick for that, what we'll do is we'll say for each int col as in column starting at 0. Okay, so starting at the 0th element for each of those rows. Running while column is less than mat at the particular row we're in dot length. Okay, now if I have a jagged array, this is important. I need to be working with kind of the column length of the specific row I'm talking about. If I know I have a rectangular array, it doesn't matter which row I use here. A lot of times I'll just use 0. But if those rows are all going to have different lengths, I need to use the length of the specific row that we're talking about here. Okay, so we'll use the length of the whatever row this outer loop's on. Okay, column go up by 1 every time, and then from there we can go system.out.print. Okay, matrix at the individual row, the individual column. Once that loop's done, we will add a new line to move on to the next line. So printing that as row equals 0, we'll run through each column in that row and print off the 5 and 7. Can then move on to the next line. Row in my outer loop will become 1, so we'll run through each individual item in the second loop, in the second array, I should say. There's the 5, 3, 4, 6. New line. Okay, row is now 2. We get the 0, 8, 9. I can also transverse a 2D array using a for each loop or an enhanced for loop. Now for that, it really requires an understanding of what type of data structures we're dealing with here. So I want to begin by going through each row of my 2D array, or in other words, each 1D array. So what I'll do is I'll say for each single-dimensional int array, we can call row in matrix. So running through each of those rows, and then for each of those rows, we'll go for each int, we'll just say num in that particular row, where row refers to this placeholder. Then we can just print off our num with a space. Once we print off everything in that row, we'll go enter. And we'll get the same thing for this line. Okay, for the first row in matrix, we'll print off the 5 and 7, new line. Then we print off the 5, 3, 4, 6, new line, the 0, 8, 9. Okay, so that's how that works with a enhanced for loop. All right, so that's it for 2D arrays. Now, it might seem like we threw a lot at you, but a lot of it works the same way. It works analogously to single-dimensional arrays. Okay, so give it a shot. Start working on some programs. Start cranking out some code. Let us know if you need help, and we'll see you folks for the next lesson.